Aloha. I didn't get you. Aloha. One more time. Aloha.
Aloha.
Good afternoon, everyone. My name is Nguyen. I am the conference chair of this conference. It's truly amazing. I'm so excited to be here for many reasons. One of it is very personal. When I got out from school from NYU, HICSS was my very first conference, and it has shaped my career. And it was in 1986, and this is in Honolulu. So this is the very first time that we come back to Honolulu, and guess what we got today? 1,400 participants, which is amazing. So thanks to all of you, every single one of you who have played a very active role at HICSS. HICSS has become really a platform where ideas meet and science speaks. I can see that in the hallway. I can see that in the conference rooms. I can see that in the pools, and I can see it even when people walking along the beach. So thank you again for being part of the HICSS journey. And then I'm so excited to announce that next year the conference will be in the Big Island. And then we are already starting to organize it. We'll discuss it with many of you guys about the ideas of symposia, workshops, and also creating new tracks and everything. So this is actually a truly exciting venue. So again, welcome to Honolulu, welcome to Hawaii, and welcome to HICSS. I am also very excited today to share with you some very basic statistics. Again, this is the very first time that we had a record number of paper submissions, almost 1,800 papers. The acceptance rate has been coming down quite a bit, at 43% right now, if we exclude the papers accepted by, written by mini track chairs and track chairs. They are supposed to be written good papers, right? So this is another amazing record that HICSS has recorded for this year. And I will try to give you more detailed information in the next coming days. But then for today, let me just ask you one question. Who are the people who've been here for the very first time? Raise your hand. Wow. This is amazing. This is one of my top priority concerns running the conference is to sustain it for a long time in the future. And newcomers are basically the future of HICSS. So welcome to you all. Okay, another interesting statistics for this year is that the oldest author that I can recognize is in the early 80s, and the youngest author is a high school student with an excellent paper, and he is only 15 years old. So with no further ado, I'm so pleased to have my president and my dean coming here to say hello and welcome to you all. So Dr. David Lassner is the president of the University of Hawaii system. Before becoming a president, he was a CIO, and he was very active in the creation of the ICT network in the world. So David, welcome.
Aloha mai kakou. It's wonderful to see you all here. And I just learned in those brief remarks 2 more things I have in common with Tung. My mom is an NYU graduate, was an NYU graduate, and HICSS is also the place I gave my first scholarly paper at a professional conference, a refereed paper. So we have both of those things in common. So I understand we have over 1,400 of you here today, which is amazing, from 45 countries. And it's always an honor for us at UH and in Hawaii to get a chance to share this place that we love so much with all of you. We're really proud to have founded HICSS 1968. And this was a really important platform for the University of Hawaii Some of the founders were Norm Abramson, very famous, passed away a couple years ago, and Frank Kuo. And they used HICSS as one of the initial platforms to launch their work with the Aloha protocols and the Aloha network. Those of you who come out of the engineering protocol side will recognize this as the technology that underlies Ethernet in all of its early forms and most of the wireless networking that goes on today, and much of the really important work that changed the way all of us work and live today. And now, 57 years later, we're still going strong with a major international platform. And I think a big reason for that is just the dynamism of the leadership of the conference to always be adapting to whatever is really important and support truly cutting-edge research. And I'll ask Tung later what the 15-year-old wrote about, because I'm super curious about that. But moving from bringing together really business and technology and information systems, but with a strong focus on applications and how our lives are enriched through the work that all of you are doing on the research side. So, obviously emerging opportunities and challenges right now. The biggest one that slammed everybody in the face over the past year, if you weren't thinking about it sooner, is artificial intelligence and machine learning, which just opens up an incredible array of questions and possibilities. And I know many of you are doing amazing work in that space as well. And that will be the case from here on out for many years to come. I'm also really happy at the University of Hawaii, we've set a really strong priority on diversity, equity, and inclusion. And this year, HICSS has a special track on that with more than 80 papers received, just trying to see how it works. And it's great to see those of you who are here today and the diversity that you represent, just looking around this room. I can say this as an old white guy. It's really good to not be looking at a room full of old white guys. But apologies to the rest of the old white guys who are just. And finally, Tung mentioned my previous job as CIO and this amazing place, and I had the opportunity to organize a fair number of international conferences, including here at this hotel. And I know how much work it is, so I just want to publicly thank and acknowledge Tung, who took this over from his predecessor in the College of Business, Ralph Sprague, who ran HICSS for many, many years. And Dean Mantroli, who's up next, who has really supported it with the entire platform of the college, standing behind the importance of this conference, not just to our Scheidler College of Business, but to the whole University of Hawaii and the state of Hawaii in the Pacific. So mahalo to you and the entire team for keeping this thriving so long. Aloha and have a wonderful time.
So thank you very much. And it's a pleasure of mine to invite my boss, Dean Mantroli. He's known to be probably one of the most successful fundraising business dean in the country, if not in the whole world. I don't know how many millions you have collected since now, but you might want to say it to the audience. Vance.
Thank you very much, Tung, and welcome to the 57th Annual HICSS Conference. And I'm following my boss here, Tung, and President David Lasner, so it's always a pleasure to see David at one of these events. We look forward every year to starting the new year with a HICSS Conference, and the same is true in 2024. As was already noted, this is the 57th year of this conference. This is the longest standing conference in the MIS, Computer Science, System Science fields in the world. And it's grown tremendously since 1968 with over 1,400 registrants. And again, attendees from over 45 countries. So you're all very welcome here in Hawaii. This conference is known not only for the quality of the research, quality of the papers, but for the opportunities to initiate new research ideas through the networking opportunities that you have here during the conference, and we know that you all take advantage of that. This conference, I was always been struck by the fact that here we are located in a beautiful resort here in Hawaii, yet I see no sunbirds. I mean, you guys are actually serious conference attendees, so congratulations on that. In addition to HICSS, which we are very proud to support, it's been another remarkable year for the Shriver College of Business. We've continued to do very well in faculty recruiting, and our alumni continue to give us tremendous support. We launched a program this year, programming for RISE, Residences for Innovative Student Entrepreneurs, this fall 2023. And this is a brand new 350 bed dorm with space for programming by our Entrepreneurship Center, Pacific Asia Center for Entrepreneurship. And there are only 4 such centers like this in the United States. And we're very proud of launching this, and it's been a huge success right from the start. So hopefully that will continue. So this year also something new is going to occur. So in addition to the role of HICSS as a major platform for academic and non-academic researchers to meet annually, there's going to be an opportunity for visitors to interact with our Shriver College faculty. This year, the Shriver Information Technology Management Department is launching a post-HICSS conference at the UH Manoa campus with the participation of a dozen researchers attending HICSS, featuring responsible information systems. So that sounds fascinating. So on behalf of the Shriver College, also would like to thank Professor Tung Bui for his leadership, not only with HICSS, but as a recent former department chair of the ITM department and as our faculty director for our Vietnam Executive MBA program. Does a remarkable job. And I also want to thank him for keeping his pledge so far of not retiring before I do. So thank you, Tung. I don't know where we'd be without him, in fact. I should also note that this is my 20th time that I've been fortunate enough to welcome this conference. So how many of you have been here at least 20 years? Much fewer hands for that one. My 20th time, I landed here in January 2005, and one of my first tasks was to fly, I think it was to Maui, to welcome this conference, and I thought this is going to be a great job. But again, welcome to Hawaii, welcome to HICSS, and I really hope that you have a fantastic conference and time here. Thank you.
Okay, David and Vance, we go on business right now. Okay, so it's a very pleasure of mine to introduce a friend of mine, a graduate from MIT in mechanical engineering. He landed a job in California State University, Northridge, and he got $8 million right away from NASA to build a lot of applications with robots. So he promised me at lunch today that next year he will bring a robot on stage and doing the dancing aloha dance with all of us before we start the business. So Dr. Ho is going to introduce the keynote speaker today. So welcome on stage.
Wow, aloha, especially to those of you who are attending here first time like I do. It's a pleasure to introduce Dr. Christopher Nguyen. You've probably seen a lot of him on YouTube, on LinkedIn with his newsletter and him all over places. But I think what you don't know about him is there's sort of like a personal legend story that I want to share with you. He was actually a Vietnam War refugee. And when he left Vietnam, it was on a boat, and he was tasked with doing the ocean navigation, which I was just told that he ended up in Malaysia. so, so I think, that's just tremendous motivation for Dr. Nguyen now to work on the industrial AI for marine navigation, among a lot of other applications. So without ado, please give me a very warm welcome to Dr. Nguyen.
All right. I apologize for being slightly overdressed. I flew in from Tokyo, and believe me, I had a much bigger coat on. So this is already stripping some of it away. Let me. Okay. I got the invitation to come and give this keynote, maybe it was 2 months ago. And Dr. Tung, sort of a mutual friend of mine, said this is a very important conference, and I love your reading, and I saw your YouTube address and such insightful stuff, from my experience at Google and Panasonic, and the stuff that I wrote. There's an article, I think it was like shining the light from industrial beacons or something, and Dr. Tung said, I would love for you to come give this keynote, and I'm wondering, wow, that's such an honor. Why would somebody invite an engineer to speak in front of a bunch of executives and MBAs? And I said, yeah, I'd be happy to. I'd be coming back from Asia at that time. And then indirectly later on, I found out that somebody else canceled. So good luck, I'm your second choice. But I'm always glad to be at the top 43%, right? That has always been my academic dream. All right. So I've been lucky to have lived a very long life, and so I've done many different things. If you use Gmail, that was one of the products that I launched in the early days at Google. But that's sort of, I grew up my PhD from Stanford in electrical engineering, and believe it or not, it's on device physics. But most of my career has been pretty much digital. I was a hacker, arrived in the US, luckily, at the age of 13, and my first PC was a TI 99-4A, which, separates the room into, 5% and 95% in terms of age. But it was after the acquisition of my previous company by Panasonic that I kind of returned to the physical world. And so today I want to share with you, sort of what I learned, what I relearned in the last 5 years working at Panasonic, running global industrial AI there, and working on things like, for example, how many people here know that all of the batteries for Tesla, at least up to the time of China, were actually made by Panasonic, right? And even to this day. So where does this come from, and what have we, if I can say, the Silicon Valley as a term, which I include most of the audience here, and this idea of this digital world, where have we been in the last 35 years, the 30 years or so, and what does AI have to do in terms of this watershed moment to the physical industry? Okay, I always like to start with a pop quiz, right? I was a professor once. I just found out that when I actually started at Hong Kong University of Science and Technology at the same time, and we didn't know each other. That's kind of weird. Of course, I was the triple E guy, and he was the business guy. But there's this annual survey, right? In this case, it was done by World Value Survey, and people ask these questions all the time, and you can plot this. And let me get rid of the tabs here. View full screen. Okay, all right. People would be surveyed and asked about questions. How do you feel about technology? What do you think it's going to do to your life? Do you think it's going to take your job, or it's going to make you more productive, and so on and so forth? And then you can compile, and somebody compiles it in terms of 50% and above would be optimistic, and 50% and below would be pessimistic. And I decided to take that data and then plot it versus GDP per capita, right? Being I know a little bit something about MBA and business and stuff. So as you would expect, right, richer countries tend to be more optimistic about technology, right? This is just the data and the correlation or the trend. The R squared here is about 0.37. So the trend is pretty strong. United States, Australia, and so on. And then somebody thought to do this. I think it was, anyway, the slide will remind me, to ask this question a couple of years ago about AI technology. Now, how many people here, I'd like to show, every time I ask this question, only 10% of the audience have an opinion. So I'd like to get that to 90%. The first question should be easy. How many people think, as it relates to AI, the same question but applies to AI, that there is a correlation among among people across GDP per capita? How many people think there is a correlation? Okay, good. All right. How many people think the correlation is the same? That there's a trend is the same. That is, richer countries are more optimistic. How many people think it's the opposite? Right. It wouldn't be an interesting talk if it's not, right? But it's actually quite amazing. Look at this, right? And again, we don't have to know. When I talk about my team and making decisions, so we can separate the what from the why, right? We know the what is very clear. We can speculate as to the why. You can see very clearly here, almost the opposite. The U.S. over here, Australia, France is always super negative about everything. So, but India, Peru, and so on, right? So we can venture, and I actually posted this. The study came out from Stanford HAI, but it was Ipsos who did the survey. And I posted this on Twitter, and people offered all kinds of explanations, right? And I think there are probably multiple factors. But one of the things that I like to think about is that it has a lot to do with this, right? I think a lot about, I also, apart from my previous life as a professor and corporate executive, I also build companies. So I think a lot about the timing of things, right? Building startups is not just about technical or business, even a business idea, but it's also timing, right? So there's something very special about this moment in what I'm going to use the broader term generative AI now, that suddenly unlocks what has been very much pent up. Right. When I think back about the machine learning stuff that we worked on at Google, many of you probably enjoy very good anti-spam detection and so on. That's machine learning. For the most part, the last 20, 30 years have been about applications in the digital world. And there's something very different about that. It's digital in, digital process, digital out. And the data itself that we process at places like Google, Facebook, and Twitter is inherently compatible with machine learning. And in fact, you think about it, it kind of makes sense that since 2012, you got the YouTube videos that came out, that famous Google Brain paper on detecting cats on the internet. But the industrial world and the world that I was sort of steeped in or went back into after the acquisition of my company by Panasonic was actually much more difficult. Like a lot of techniques that I tried to apply, time series, predictions and so on, LSTMs, recurrent networks and so on, we just could not solve simple problems. Well, not simple, but solve very well understood problems like predictive maintenance, right? And it turned out that the insight that I got was that the techniques that we have developed are far more suitable for a world that is rich in data for machine learning. It may seem like there's a lot of IoT data, there's massive amounts of data, but that data is actually not compatible for predictions of failures, right? So for example, if I run Gmail and I want to predict the click rate on an ad or something, by evening I've had 100 million data points. But if I want to predict whether the compressor is likely to fail over the next 30 days, this particular compressor in that store, under that workload, in that climate. And I look back at my 10 years worth of data, I have 3 examples. So what's different, and I hope through this talk, if you hear nothing else from me, is that there is something very significant about today's moment in terms of generative AI that solves that problem, that makes that problem easier to address. okay? And so what I learned at Panasonic is that it turns out whatever it is you do, you can have a lot of data, but every domain has its domain expertise, right? And the domain experts, for different reasons, I'll give you one reason, is that there's mental models that have been built up over 30 years, institutional memory, institutional knowledge, physics, experience. This compressor may look very different to the sensors, but it's actually the same physical principles, right? It has evaporator, it has condensers, and so on. It works, just this refrigeration system works in the same way that another system may work. So domain expertise, we leverage that a lot at Panasonic to solve problems of predictive maintenance in addition to machine learning. But it's been very costly to apply until now. And I think now, how many people have I expect this to be 100%, but close to it. How many of you have used ChatGPT? Exactly, right? The special thing about ChatGPT or GPT is not the intelligence, right? It is partly that, but to me, the special thing is the communication. For the first time, our machines actually understand us. That's what's different, right? I spent the last 30, 40 years trying to essentially encode basic intelligence, rules. If A is greater than B, then do C, right? But now we have sort of basic understanding of these things in natural language. So the domain expertise that I was working to encode, right? If the pressure has been rising while the temperature remains constant, it's very likely that the compressor is the problem. Something like that. It used to require a Python developer, a computer scientist, or maybe a rule processing engine, but can now be at least communicated directly to models like ChatGPT. So we can unlock massive value with generative AI for the physical world for the first time, right? Because for the first time, our machines can understand us in natural language. But it wouldn't be too interesting if I'm just here to tell you LLMs are great, right? Everybody understands what LLMs are, large language models, right? In the limit, these are just models that we've been building, deep learning model, neural network models. They're just a lot larger in terms of size and fed with a lot more data. And suddenly some kind of world understanding, world model emerges within these models. And so I'm going to make a right turn here, and I say, but they're not enough, right? So there's lots of companies now that are being built that are sort of thin layers on top of these LLMs, and they're making money generating messages and chat and advertising, copy and so on. But for the industrial world, and increasingly some of the problems that you folks here are going to be working on, number one, they lack domain-specific knowledge, right? These large models. Sam Altman has recently come out and said, okay, we've come to realize it's not going to be one or two large models that rule the whole world. It's going to be billions and billions of domain-specific, personalized models and so on. The second thing that businesses, like Panasonic, like Hitachi, like Furuno and so on, are very concerned with is that they don't want to pay yet another, I'm going to use a term in the generic sense, they don't want to pay another Microsoft tax, right? People are paying a lot in terms of the IT side already, but on the OT side, the operational technology, they're not used to that, right? And more importantly, they want to make sure that the domain knowledge that they have, their own IP, will remain their property, right? Will be leveraged by them. So the large models that are sort of vendor controlled, that business model is not compatible with how the industrial world looked at things. And quite importantly, right, they are largely in simplified terms, they're Q&A, question and answers versus problem solving. I'll talk a little bit more about the significance of what I mean by that. Okay, so industrials need solutions and not just answers, or answers versus solutions. I thought a lot about how to explain this, and I do give kind of thought leadership talks to CxOs, and if I make it too technical, people say, well, I don't understand. For example, I talk about hierarchical planning, long-range planning, and deliberative reasoning, and so on. But that's, but there's a much easier way to think about it. So many of you here, people who hire people in MBA school, and essentially if you're presented with this case, right, there's two candidates, A and B, and like Warren Buffett says, right, intelligence, energy, and integrity. You need all three, because if you only got two, the other one will kill you, right? So you need smart, honest, and hardworking. If you have these two candidates, which one would you hire? Same, right? And then so you make a reference call, and then you realize, the former manager say, well, A is actually very smart, very honest, and very hardworking. But the way he works is that he sits in this room, and you can go in and ask him almost any question. You can train him. You can hire somebody who's domain specific, and you can ask a question, and then he'll give you the answer. And a lot of times the answer will be correct. Okay, so that's a very smart, honest, and hardworking. And you go in and you say, I got this problem. What me would do is sort of run out to the world, figure out what's wrong, try something, it doesn't work. The world has changed, and then, she'll try again. And then finally, when she comes back to you, the problem is solved. Okay. So that's the difference between Q&A and problem solving. Now, which candidate would you hire? Okay. So that's pretty clear. The limitations, we can get technical, of LLMs or large X model, these are now multimodal, are that they are sort of atemporal. They are one pass, input, inference, output, right? To do long-range planning, to actually solve problems while the world itself is changing, you need iteration, you need a loop. And the loop currently doesn't exist inside this model. That's essentially why, right? And Nguyen LeCun, right, the head of research AI at Facebook, also talks about this at a much more technical level. And this is sort of his architecture for autonomous machine intelligence. And more of us are starting to realize this, right? And I know there's a question that some of you are going to ask, but LLMs clearly reason. And I don't have time to take in my talk. Maybe I'll leave it for the question and answer part. I'll go deeper into that. But essentially, you can see the architecture here has recurrence, has this loop. It repeats itself, right? And there's work that I'm working on right now called Reasoning Through Recurrence Neural Net Architecture with Temporal Dynamics and Vertical Feedback. So this does get very, very technical, but just remember, if for no reason, then, the difference between Q&A and question and answer versus problem solving. And so clearly, industrials, if we're going to apply this wonderful new technology to solve some of the existing problems that we have, right, in supply chain, distribution, oil and gas, and so on, we need to have the ability to have systems, right? And I'm so glad that the word systems is in this conference, right? AI, the model is a model, but you will see very soon that when it hits the real world, you're going to need systems for which these LLMs, these large vision models, and so on, they are components of the system. They seem very large right now. They are the new, flashy object. But until they become components in larger systems that we control and that we put in these problem-solving loops, they are not enough. Okay, and anyway, these are some of the use cases that we're actively working on at my company. You can see these are names that when I show to my friends in Silicon Valley, they don't recognize the logos. Maybe Panasonic, and then they'll say, "Oh, that's a TV company." No. So the basic architecture looks like this. You can see that on the left-hand side, there are sources of data coming in. What's new is that now there's a field personnel, meaning his or her, we separate between what we call documentary knowledge and experiential knowledge, right? People in this room have both. You have both what's in your head and also what's in the books. You notice a lot of the technologies or product that you see today, what they do is they go and they look at some documents and they sort of answer questions out of there. That is not enough, right? You have to capture the experiential knowledge of the people working in the field. So I'd like to share with you a little bit of that difference. So we'll go, I don't have full time to do a whole demo, but I have, how many people here work with something like called IPython notebooks? Okay, the 10% that are CS folks? Okay, let me see if I can. Okay, so I don't have a nice UI to show you, right? Like a product demo, but the product does look something like this, and people would interact with it, and they would ask questions, and there's something called advanced reasoning over here, right? The capability that I'm showing you is hot off the press. I was working with my team in Asia just this past week before flying back. That's why, and so I can only show you the studio code version of this. The idea of this is that there are two ways. But by the way, this is a very specific application. A customer or a industrial would say, I have these documents, and they come from operating manuals, they come from working logs and so on. Can you feed it into your system somehow and then have me or have my team start asking questions based on the information that comes from that? Now, if you take a moment to think about that problem statement for a moment, you see that there are two ways, two sets of behavior. One is kind of like just a search problem, right? It's just very fancy, what we do all day today when we do Google, for example, right? You do the search and then you look through the relevance. Well, Google does a little bit of that for you. And then you integrate all of that together and then you come out with some kind of understanding and then sort of repeat that, right? And now we can automate that process. But the question is, when the relevant pieces of documents come back, what happens, right? Either one of two things happen. Either it comes back, and let's say I ask a question, how heavy is the laser machine? And let's say in that document, there's actually that information in the manual saying, when you ship this, be aware that it's going to be 1,500 kilograms. And so that is a Q&A, and it'll answer that question perfectly, right? Because it does a search automatically, and then it can read that in the text in natural language, and it can infer from there that it's 1,500 kilograms. But what happens if that particular fact is not in the document? That technique will fail, right? How many of you have worked with systems or have heard of something quite emerging called RAG, Retrieval Augmented Generation? Exactly. So I'm here to tell you that's what RAG is, and therefore, no matter how hard you work at it, it will be limited by the way I just described, right? It'll only be able to read that text that it retrieved. It will have no special domain understanding beyond that, right? So, in other words, in the field, when we actually do something like I just described, and there's a system to evaluate the accuracy or the effectiveness, basically people come back and say it's 50-50. Right? And that's actually terrible, right? You need it to be at least 90%. 50-50 means, I might as well just look it up myself. And so that's the difference. It lacks the reasoning, the sense. There's one example that my team gave me where it's in the title, right? A piece of equipment, and then the dimensions are given, right? And then the question is, how big a jig can I fit into this, right? Now, I just gave you that information, and in your own human brain, you already process the relevant. Oh, it must be related to that, the dimension of the thing. It's a 50 centimeter. But since that is not stated as a fact, the RAG system is unable to answer that question. And the customer or the people will just say, I'm telling you the dimensions right here. Why don't you know that the maximum jig size, well, the word maximum and things is not in there, right? So in any case, many of us are now starting to build reasoning engines behind that, right? To do what you just did in your head. And this is one that's just showing you, there's a bunch of code, but I'm showing you sort of the result of some of this, right? And you can compare the two. So here are some questions. Okay, so this is a good example right here on the screen. You can see that, right? Is it preferable to use nitrogen when printing with titanium? Okay, and this is a 3D printing company, industrial 3D printing. And I don't have the text here, but somehow the RAG system comes back with, yes, it is preferable to use nitrogen when printing with titanium. Okay, that text is probably somewhere and it sort of misunderstands the context. The longer reasoning system says, no, it is not preferable to use nitrogen when printing with titanium. Only operate the machine with argon as the inert gas if you use titanium powder. Okay, so where does all that come from? And I'll show you a little bit here. It comes from a loop that does reasoning, okay? And some of you, if you're old enough and you work in the Air Force, you may be familiar with the concept of the OODA loop, right? How many people understand OODA loop, right? So there are many decision-making frameworks. One of them is by this Air Force general for a tactical fighter jets or something. Observe, orient, decide, act, right? So this is a meta loop outside of the LLM. So instead of asking it, say, look at this and then tell me what you think, they say, no, first observe. Okay, now what do you think? And then it'll output some tokens about that observation. Now orient, reason through. And it actually does that. And then decide based on this information. So for example, we always start saying, based on this, do you think you can answer the question? Right? You can talk to it almost like a human being. But if you ask the question directly, you'll get the wrong answer. But you say, you think you have sufficient information to answer this confidently? He might say, no. Okay. Then you say, the next OODA loop, what information do you need to answer this question more confidently? You say, well, I need to know the maximum size. I need to know what the jig size is. And so then it generates a whole bunch of activities that goes out and retrieves this information. That's the basic fundamental idea. Instead of just using these LLMs as question and answer machines, you say, let me walk you through the process of figuring this out. And even figuring out the walk is also assisted by the machine. So that's actually a very interesting pattern, right? Now that we've all been exposed to ChatGPT for more than a year, and I'm sure you are talking to your students and others about what are best practices for using ChatGPT or systems like this. To me, there is one very important dichotomy, and it is this, right? You either use it as a teacher or as an assistant. And I believe it is far more effective to use it as an assistant, right? Not a teacher. People who go to that ChatGPT window and start asking questions, you're going to get hallucinated answers, right? The executive function, right? The direction about what to do has to be yours for quite some time, right? And then, but it could be very powerful at helping you, right? It can help generate ideas, but you just have to filter through the ideas, right? I am a much better CEO today than I was, 2 years ago. But that's how I use ChatGPT, right? This whole presentation was AI generated. Well, but I directed it, right? Okay. So let's go back. Let's resume. Okay. So now that you see that one difference, let me talk about the whole framework of differences. Through talking with a lot of executives and what they care about, and people always like to have acronyms to remember things. I came up with this thing called SOLID, right? But the S stands for size, O stands for ownership, L level, I industry, and D domain. It turns out the future does not belong to large models. The future belongs to small models. You start out large, right, to get this world understanding, but very quickly you find it's far more efficient to, number one, deal with domain-specific models, because they would, when I'm working with a compressor, I don't need that model to know who the US president was in 1875. I can strip all that away. I can quantize it. I can prune it. At the same time, I need very fast responses, right? I don't know whether you work with budgets for your IT and your information system, but it's very, very expensive to do inferences, to large models like ChatGPT. Right? So the industrials want these smaller models that they can deploy in a car, in a factory, with a piece of equipment, and so on. The second thing is they also need to know that they own it outright, right? And it turns out open source is a very good way to do that, right? You start out with open source models, you fine-tune them, you train them, and then you quantize or you compress them. But then the industrial companies, these customers, they need to know that we're going to own that, and we're not going to be stuck with someone else's IP or having to pay rent to them, perpetually. I shared with you the idea, the level of intelligence, right? Some of you may be familiar with this concept of system 1 intelligence versus system 2. That corresponds to what I said earlier about Q&A versus problem solving, right? System 1 is quick thinking, inferences, and so on. Level two is deliberative reasoning and long-range planning. And so we really need that in the industry in order to actually solve the problems of, say, diagnosis of machine failure or predictive maintenance. The industry that we work in is very much the physical industry, right? And they want to deploy critical physical apps, right? There's an emerging area, and we're all concerned with it. It goes by different names: trust, right? Safety, reliability, and so on, right? And I'd like to remind my friends in Silicon Valley that it's nice that we are now touching toys that affect people's lives, and we're worried about it. But remember, companies like Panasonic, companies like Toyota, right, and Siemens and so on, they've had to wrestle with the safety of physical systems for 100 years. So there's something we can learn from them for that. And of course, I mentioned the domain specificity of these agents. So SOLID is the framework that I share with people in terms of how they should evaluate technology, right? When something is brand new, it's a big blob, and it's very helpful to be able to divide them into binaries so you can make a choice. It doesn't mean that one side is always better or more appropriate than the other, but it's very good to be able to slice these things up and think through them. The stuff that I showed you earlier is actually open source. It's called Open SSA, Open Small Specialist Agent. And before I close and open the floor for questions, I want to share this additional perspective. For various reasons, some of which is commercial, some of which is geopolitical. So this op-ed came out with the Nikkei, and you won't see this, or at least I've not been able to search for it in English. It came out after Sam Altman visited with the Kishida government back in April. And of course, Sam has been now going around meeting with various prime ministers and presidents and so on. But immediately after that, Kishida-san convened his cabinet and said, let's update our AI policy, right? And if you read the English translation of this, it says the U.S. already, this is the Nikkei op-ed. The U.S. already controls much of the digital technology infrastructure, such as cloud services and search engines. Missing out on the wave of new innovation represented by large-scale language models would not only mean a lost growth opportunity, but also pose a risk to Japan's economic security, right? And I picked Japan because it's sort of one of the least obvious countries that would be concerned about being controlled, by an adversary. But the language here, the idea is that countries, certainly companies, are today very, very concerned about the power of this technology, right? Some of the discourse actually goes as far as comparing it with nuclear power and the fact that we need to control it and have treaties and so on. But I think this is a major motivation for open source. Openness is key to this AI independence. And in fact, Aitomatic, I am one of the founding members of this thing called the AI Alliance with IBM and Meta and so on, committed to open development because we actually believe that openness is actually the key to safety, right? The ability to scrutinize, the ability to evaluate and move forward together is the key. And that sounds so obvious 10 years ago, but it's becoming actually the fear that is now present in the world because of geopolitics, because of AI and so on, is actually making what I just said slightly controversial, right? People are saying, shut it down, don't open it up. So I'm on the side of trying to push it to be more open, not less. I want to close by reminding this is a talk that I'll also be giving in Santa Clara next week. As I start learning or relearning industrials, right? This is where Silicon Valley came from, after all, right? But the last 30 years, our friends, Mark Andreessen and so on have been saying software is eating the world. But in fact, right, what has happened to America in the last 30 years as we've outsourced everything, and we're trying to bring a lot of that back. We're not bringing low-cost manufacturing back. We're bringing manufacturing back together with this kind of science, this kind of AI, to increase the productivity. Because look at the shortage that is being forecast by McKinsey. I don't know how you feel about Elon Musk, but he does get a few things right, and he himself has criticized Silicon Valley VCs for a massive misallocation of capital, right? And I think, he's correct, and he has proven with Tesla, with SpaceX and things. There's epic success. Those of you that are thinking, after this talk and say, hey, maybe I should do something in industrial AI, Elon promises epic success for talent in manufacturing and heavy industries. And that's what I'm here to share with you. All right? Let me stop here.
Thank you very much. You are right on time. The backup solution is not the best solution at all. So this is right on time. So we do have about 10 minutes for Q&A. So I would like to invite the audience to ask the speakers some questions. Go ahead, please.
Oh, great talk.
Can you stand up for that?
Sometimes the machine learning makes something up, it hallucinates. To me, that is just as important as veracity in the data. So how can we validate, to make sure that we're making good decisions? Because like 10%, 90% may be good for some things, but 10% could be very bad for certain things, like, for example, our flight back.
Yep.
10% of us don't make it back to our destination. That wouldn't be a very good thing, right? So the question about how do we validate?
Absolutely. Yeah, I just came from Haneda Airport, and 6 hours before I took off, there was this fireball. So I'm quite concerned about flying home safely. I think your question has two parts. The question has to do with correctness or even truth, right, in these systems. And the two parts are, number one, making it correct in the first place, and the other is a verification, right? So in fact, there's an emerging whole field about just evaluation. If you have these Q&A systems, how do you know that they are performing effectively? Other than just a human sitting there and say, I'm going to sample a few. So we're building kind of like who guards the guards, right? So we're building systems to evaluate these answers. And of course, we use LLM technology for that as well. But in terms of making it correct in the first place, let me try to collect and say this way. It's very important to fix the hallucination problem. But if you think of it in terms of a system, it is actually incorrect to focus only on the hallucination problem. And the way I described it is that if I took my brain and I sort of take it out of my head, out of sensors, any sensory perception, no eyes, no ears, and so on, and I hang it on the ceiling, that brain will start hallucinating, right? Like it's always inferencing something. And a lot of hallucination problem that we see is when that's consistent with what I said earlier, is that you got to think about these things as just components in a system, right? There is no intelligence except embodied intelligence, right? Intelligence is actually very specific. We learn things evolve to fit our world, right? There's no absolute zero, contextless intelligence. So the point is, we got to hook, once we hook these LLMs to, for example, data sources, databases, search engines, right? In the case that I showed you earlier, it actually reaches out and then go look for other documents. Then the problem hallucination, the effect of hallucination, the fundamental ability to hallucinate will still be there, but as a system, right, the percentage of errors that you get will decrease automatically. In other words, don't trust me unless I am also armed with Google, with encyclopedia, with the way to look things up, right? If you just try to get information directly from my brain, it is far less reliable than if you allow me to access other sources of information.
Yeah, please go ahead.
Can you hear me from there?
Yep.
So just a few hours ago, OpenAI announced that they're going to open up their small language model GPT store next week. And simultaneously, a few days ago, they just empowered Bing on creative mode to use GPT-4. So this is for free. How do those two events change your conclusions from this keynote?
Which conclusions? The physical world?
I'm going to let you decide which conclusions you would like to change, or does all of this still remain relevant given these two new events?
Oh, absolutely. Those things are well predictable and predicted. In fact, I was in the Saigon, Ho Chi Minh City. Was it Hanoi? Ho Chi Minh City, right. 2 weeks ago, and Sam Altman was one of the fireside chat invitees, and we asked him specifically that question, and specifically on the dichotomy of OpenAI not being open anymore. And it's actually on record. You can also look at my tweet, and he said, look to OpenAI to open more. And this is just one step of many of those things. I think the way I would think about it is that any single thing that OpenAI does not change the trajectory of the world entirely. It seems that way, but OpenAI and other friends of mine realize that they are contributors to a much larger ecosystem that is still evolving. The conclusion of going, that is, large models will not solve everything, but then we need to compress them, and then we need to make them domain specific. I think I would call it as inevitable as evolution, right? In other words, there's 7.5 billion of us on this earth. We're all very powerful LLMs, LVMs, and so on, but somehow we have evolved to become specialists that can combine into a team of 3, of 5, of 100, and so on. It is a far more efficient way to organize than to have one gigantic brain human that says, I'm going to be the boss of all of you and I'll take care of everything. It's just grossly inefficient. So I think anything that OpenAI does is just a small tick in that perspective.
So you called it Jean LeCun. I really like that. And in one of his talks, he said that large language models are missing the ability to reason, so they can't. They are sucking at math, and also if you want to play chess with them, they make some illegal moves. So shouldn't we concentrate on the next stage of models that have really an understanding of the world instead of just jumping on a train that's already, nearly gone?
The second part, jumping on a train that's gone, meaning?
I mean, we try to,
Just scale it up.
Source thing.
Yeah.
Why are these companies doing it open source? Because they are afraid of this one big player, OpenAI, having all the market, and then everyone has to pay. So they decide to go open source, not because they like the people, but because they don't want to fall behind. That's the reason why they go open source. But we could also go a step further and try to build advanced models that have real an understanding of the world and can actually reason, because that's one lagging thing of large language models. They have a language understanding, but not an understanding of the world.
Right. Okay, excellent question. Let me be very confusing, speaking out of both sides of my mouth. I have this axiom. Again, you can probably find many things that I talk about on Twitter, on X. I say there's an unspoken axiom of Silicon Valley, which is closed when you're ahead, open when you're behind. and people say, "Oh, Christopher, you're just being too cynical." And I say, "Well, it's true. It's the altruistic motivation is simultaneously true with that, right? Lots of companies, when they are behind, I remember the data centers of Google at the time. We didn't even patent things, because patenting means you would disclose some of your techniques, and so that motivated Facebook some years later, 2009 or 10. To start Open Compute Framework, OCF, to essentially say, okay, we're going to be sharing information, our knowledge, learning, and so on to sort of try to compute. So there's certainly that aspect. But I think what the thing that I shared earlier, there's a fundamental difference between open versus closed. It is not one at the expense of the other. It's kind of like you need both yin and yang, right? And so to your point about whether we should be working on system that Yan and I are talking about, right, this level 2, or should we just continue to scale? I think the answer is both, right? I'm here to say that it is a fool's errand to think that you can continue to scale and somehow get emergent long-range planning with this architecture, right? In other words, what we're saying is the architecture itself that is of inherent limitation. But we're also just at the beginning of that. But at the same time, we can go both horizontal and vertical, right? And the vertical, the paper that I showed earlier actually show multiple steps in the research plan. The first step is to do it imperatively, right? We actually write the control loop in Python, right? Yan's architecture is actually make everything sort of learned using the joint embedding approach. You can think of that as sort of a long-range research plan. First, we're going to build a prototype of it, and then we build a more sophisticated prototype, and as we get to the ultimate where everything is learned, even long-range reasoning as well.
Thank you very much. And earlier you mentioned the Buddha model, observe, orient, and think and act. And my question is that the step of that, potentially there could be premises before that question too. So my question is that on what level would that would be detailed enough? Like for example, OODA could be separated into more steps where you have more premises involved with OODA. So my question is that in building up on the previous question, model now only have the ability to understand the real world. So my question is that lacking on this common ground, at what level, that detail, that reasoning would be enough? So what do you think on this? Thank you.
Thank you for that question, because I didn't want to make this too technical. So let me specify the technical architecture really quick, and then sort of generalize it. You identified exactly correctly. What I didn't show is that there's a concept for that particular architecture, right? The OODA loop is not the whole thing. The OODA loop is one task, but the task itself is a series of tasks that is hierarchically planned. So the task planning is hierarchical, and then for each task, it goes into an OODA loop. So you're exactly right. One OODA loop is not enough, not even a series of them. But for example, if I plan my trip to Honolulu from Tokyo, and in fact, it did happen, right? And then the accident at Haneda happened, and I have to make some changes. So now I have a different problem to solve even before I get there, and so on. Even I walk through the door, that's a problem to be solved. So you're absolutely right. A single OODA loop is a single task, but you need a hierarchical task planner. And so that's part of that what so-called imperative architecture that I talked about. I forget what was the second part of your question?
My second question is that lacking on the common ground of the understanding of the real world, wouldn't this loop of reasoning go infinitely? There would be a infinite continuity loop, for example, opening the door to twist the handle, and then you have
solved it. So these are live research questions. But notice, I think to your larger point, what we're doing here is doing it imperatively. We're doing it in Python as it were, right? The ultimate of this is what Janke is advocating, which is, can we somehow make all of this emergent, right? And I believe the answer is yes, we can. We just have to go beyond the current architecture. And I don't have the time in the 1 minute to talk about it, but I think the key of this is that in all the current architecture, everything is feed forward. Don't confuse the backpropagation with the fact that it's not feed forward. Everything is going one direction. I think the key is when you actually make back connections, right? Not horizontally, but vertically, right? RNNs is already connecting things horizontally, but when you connect them vertically back, That's how our brains are connected. And that's actually how I believe the derivative reasoning will emerge. Right? We'll see whether in 5 years whether I'm right or not. But in the meantime, I'm writing it in Python code. Thank you.
So it's already, thank you very much. Christopher is going to stay here for a few minutes, so you are more than welcome to come up to the stage and talk to him. And for those who don't have any questions, you are requested to go back to your sessions, which will be starting in 9 minutes exactly. Thank you very much again for being here this afternoon.